This is Keith Payne with Emhotep, and we are here at Derbycon 2.0, the technology center of the universe at the moment, and we're going to go see if we can find some 3D printing and some other toys to play with. We have a little bit of applications for archaeology, Egyptology. So this is 3D printing. This machine costs about $2,000. You can build your own for $400.
I didn't even read the whole article. I was like,
but that's if you want to get a kit and put it all together yourself.
Okay, right.
Yeah.
For $2,000, this comes fully assembled.
Okay.
Do you use different materials or?
Sort of. Plastics are really the only thing you can print with right now.
Right.
This is ABS plastic, and these models here are ABS plastic, which is the same stuff that Legos are made out of.
Okay, that's what I.
Okay. You can also print PLA, which is a corn-based plastic.
Okay.
PVA, which is a plastic that dissolves in water, and HDPE, which is the stuff that milk jugs are made out of.
Is it milk jugs or milk jugs?
Milk jugs.
Okay, I was like,
yeah, no.
Whoa.
This is a lot.
There are you can get what's called a frost extruder for this to extrude frostings and chocolates and other confectionaries.
Wow.
And then there are some people that are experimenting with low melting point metals, like bismuth alloys and stuff like that. And other people that are experimenting with polycarbonate. The problem with polycarbonate is the melting point of the plastic is about 5 degrees below the melting point of the extruder.
That's cool.
Yeah.
Sorry, I didn't mean to put you on the spot with it.
No, you're fine.
So just a CAD type interface, or
What's that?
to actually design the stuff you just use CAD, or?
Any 3D modeling program.
That's cool.
So Google SketchUp to
Right.
SolidWorks, whatever you have.
Wow.
SolidWorks.
That's cool.
Yeah, I'm familiar with that. That's a Dassault Systems product.
Yes. Have you ever seen one in real life before? Here it is, right here.
So, unlike some of the printers that was using material and infused layer by layer, this takes it a layer.
No. You're exactly right. It's building it up layer by layer by layer.
All right, this is one of the objects that was made with the 3D printer. This is a lock and key, totally functional. This is an example of the kind of applications that 3D printing has. Now, can you imagine if this was an ancient Egyptian artifact and all you had was part of the base, maybe part of this, and part of this? Now, the way that it's normally done is you would take clay or some other modeling material to fill in the gaps, and that works fine. If you use 3D printing, then you can use silicone, or you can use, in this case, corn-based plastic to create the missing parts of the artifact so that you then have the whole. Now, the advantage with that is that once you have the specs for the artifact entered into the 3D printer and you have it on file, then other museums and other universities can then download the artifact and literally print out a scientifically accurate model of the artifact itself. And I think the applications of that for archaeology and in particular for Egyptology are just incredible. So let's go take a look at some of the 3D applications as they're being used at the moment.
I do need to know.
So here we are with MakerBot. This is the replicator. This is the machine that does the 3D printing that we were just looking at.
You never throw stuff away.
Let's go look.
Put it in the bug jar. I made the mistake of throwing away a hair dryer. I got it. It's not just parts. Oh, no.
All the pieces are metal rods, so I can always just increase the size and then make a bigger bed.
We've got a guy who made one
bigger
out of
bed.
We've got a guy who made one out of plexus. We also have a guy who made one that's about this big. Little tiny thing, maybe a little perk board, like wide thing. It works. We just make it by hand just for fun.
Okay. Is there any difference in why this resolution is so bad here and here but not there? Is it like speed it up over here?
No, it's part of the STL. I have no idea why.
Sure.
Are you able to print like plastic springs?
Yes.
Okay.
Bobblehead you can make Thailand and stuff.
Okay, so you could like fully key the lock and everything straight from it. Okay.
Okay, we're starting another project with the MakerBot. Are we going to do another solar panel, or are we going to do something
I'm
else?
not sure what we're going to do.
Ah, it is a surprise. So MakerBot is being primed.
Okay. Go back one more time. Go down twice.
Okay, now print from SD.
Yeah. A pedal.
Is that what that is?
Yep.
Now it heats.
Okay.
Yeah, it's the little third. It looks similar to this, but it can make a nut function up from the wing and plug it into the drive and then set 4 pins and
First of all, it's too big. Second of all, it's not printing anything.
As long as I'm not trying to use like 3D features or anything. Oh, get me, please.
No, it's not printing anything.
14 inch Broadway?
Here are the spools of plastic. Right now we're loaded for blue and white. And as you can see, they feed up into these tubes to go into these injectors, which lay it down layer by layer, taking something from your brain that's been put into computer code and then creating it in real life, 3D, in completely functional forms. How cool is that? So what is MakerBot making at the moment? Well, we're working on a model of a satellite. As you can see here, the solar panels on the side. And we are currently working on another solar panel there. And as you can see, the extruders are basically laying on layer after layer of plastic, building a 3D model completely out of just the raw materials. Yes, they will turn into one of these. All of this is coming straight from computer code that can be downloaded from the web. You can use software such as Dassault System's SolidWorks 3D with this little puppy. So if you can make it in your brain, and if you can program it into SolidWorks 3D, you can make it happen in real life. As you can see on this panel, it's a little bit rough. And the reason why it's rough is because since we're doing demonstrations here now, they have it set to print fast. Now, if they had it set to print a little bit more slowly where it could take its time, then this panel would be a lot more smooth. Here's an example of some bicolor printing that was done. It's a little plastic chip here. And the plastic they're using is the exact same kind of plastic that's used to make Legos. So it's non-toxic and a lot of fun. This little robot is a laser tag hunter killer. You do not want to be on the receiving end of this puppet. However, if you want to do some robotic archaeology, then you don't have to have $1 million in the bank. All you have to have are the right friends. One of the neat things about this robot is that a lot of the parts on it were actually printed out on the 3D printer. So when they say that this is made from scratch, it was really, really made from scratch.
It's all IR based, so nothing will project.
Roger?
Yes.
There's another Greg that works for me.
Hello, Ann.
Yeah.
misbehaving.